Hello friends, my name is Ankit Dane and I will going to show you how to design the isolated footing using software called as SAFE, SAFE. Okay, so in this video you are going to learn how to design an isolated footing. As you can see on the screen, this is the plan of our isolated footing and this is the column which overlay on the footing. So how the column overlay on that footing is, I let I denote it. The column is coming at the center of this footing, something like that. Okay, this is your column. 1 minute. This is your column. Okay, is this column is overlay on that portion. Okay, so this is your footing and we are going to design. So let first you pause the video and read all the configurations of this footing, this and this, all the configurations that I will design that column. This is the isolated footing. Sorry, I'm going to design that footing. So using the software SAP, okay, SAP for SAFE. Okay, so going to save and click on file, click on new model, wait some and for once, and then design code. Select design code is IS456. Design preference is taken as IS456 and minimum cover we providing of 50 mm and also we provide cover at the bottom and top both 50 mm. Change the bar size, we are taking 12 bar size and all things are be okay and click on ok. And job information, you can fill job information. I am not filling it, you can fill according to your work unit. You can you we will take metric SI unit. Okay, so metric SI unit and click on blank. Now you can see a blank window is open now with grids. So now we having the working space. Now first we define the materials which we use to draw. So for that, click on define and then click on material and then click on add a new material. Again, I will show you how to do that. Click on define, click on material, click on add new material. Now here select the concrete material. First we provide concrete material, as you can see here, M25 concrete, and then we provide Fe415 steel bar. Okay, so M25 steel concrete and select on concrete. Modulus of elasticity of concrete is 2500 according to IS code. Okay, according to IS code for 25 M25 grade, modulus of elasticity is 2500. You can understand this by this expression. E is equal to 5000 under root FCK, where FCK in our case FCK is 25. So you can calculate this and the calculation give the answer as 2500. So we provided this 2500. Okay, and this is your specified concrete compressive strength is 25 Newton per mm square, because in 25 grade of concrete we are using. Let I capital it. Click on OK. Now provide the next material, which is Fe415 steel rebar. Okay, so you can see Fe415 steel rebar. Where is that? There, Fe415. Okay, Fe415 steel rebar. So we'll providing and select rebars and the modulus of elasticity of concrete is 2 penta 0. Okay, 2 into 10 power 5 is the modulus of elasticity generally for steel staking, and all thing are okay. Here yield stress is 4 on 5. Okay, and ultimate stress is 500 and click on ok and click on ok. Material has defined now. Now we are going to define the slab. Okay, slab, which slab? We are going to define this slab. Okay, 2 by 2 meter slab. For that, Going to software, the slab, let it name as slab, okay, 300 mm thickness, therefore slab having thickness 300 mm, therefore I am uh, giving the name as slab 300. Select the material M25. Don't forget to click on footing because this is the footing, okay, and then give the thickness as 300 mm and click on OK. Your slab is provided now. Now we are going to provide define column. Okay, this column, as you can see, this column is lie on that footing, so we need to define column separately. So we go to define, for that go to define, then column property, then add a new property, and then give the name to the column as column, okay, sorry, column. Okay, column size is 200 into 500. You can see here we are providing the column of size 200 by 500 and you can select there M25 concrete, and this is rectangular, and the one dimension is 500 and other dimension of column is 200, and all the property are same. Click on OK. Now we have been defined the column also. Now we have to draw the grid lines to draw that footing. Okay, we should in software, in CSI software, SAP software, depth SAP, all required if we want to if we want to draw anything. So we need grid lines. Okay, so we don't have specific grid spacing. So we how the grid spacing are required, here you can see we need to 2 meter in x direction and 2 meter in y direction grid spacing are required. So I will provide a 1 meter by 1 meter, 1 meter spacing. Okay. So let going to again this software and click on this working space window. Right click. As you right click and window open, click on add modify grid data. Click on modify, and now click on spacing. We provide spacing for x direction. Provide 1 meter and again 1 meter and again 1 meter. We provide three times spacing in one x and three times spacing in y. And don't forget to change this story height below, which is 3 meters, so we given it as 0. Okay, so all things are correct, right? This is the bubble size. You can see, if you want you can change bubble size. Okay, here 12,050, 1250 is the value of bubble size. As you reduce this, bubble size get reduced, but we are take it as constant as it is. So click on OK and click on OK. Now you can see a grid is generated now. So this grid will help us to draw the slabs, columns, beams, slabs and beam. Now we are going to draw this footing slab. Okay, so for that select this quick draw slab area, and here check out slab 300. Okay, which is footing. Click on that and click on that bounded areas. As you click on the bounded areas, automatically the slab has drawn. Now cancel it. Now if you want to see 3D view, so click on this 3D tab. You can see the 3D view of this also. Now I will going to draw columns. So for that you can see on left vertical menu bar the draw column. Click on draw column sign, and here column of size this, and here you take property above and below both same. Okay, and you can change height above, so how much height of column you want to take. You So I will take it as 2 meter column. Okay, the height of column is above the 1 meter. My video is recording. So and minute. So 1 meter is the height of column, 2 meters is the height of column, and now 1 minute. Okay, so drawing we are draw the column. So put the height of column above. Okay, we are putting this value wrong. So putting that value as 0 and putting this height above as 2 meter. Okay, and then you can see the column is having shown. So click it as on the center of our footing and escape. Our column is defined now. Okay, now we are going to assign the load on this column. You can see the uh, load on column is 400 kilonewton. This is the 400 kilonewton load applying on the footing. Okay, so we are going to applying the load of 400 kilonewton on that column position. Okay, here you can see the ultimate load applied is 400 kilonewton. So going to that, and first we define the load patterns, how much load, how kind of load are applied on the footing. So first is dead load, second is live load, and third one we provide as going to add new load pattern. Okay, and we are providing it as ultimate load, right? Load ultimate load, and check it as super dead load, and keep scale factor as 0, and you can add load pattern. Your load is added now, you can see here, and click on OK. Now this is the top center position of your column. You can see here, 1 minute. You can see here, this is select that column, point of column, this is, and then going to assign the load at that point. Go to load data, go to point loads, and here we select is the ultimate load applied in gravity direction is 400 kilonewton. You can see here the load value is 400 kilonewton. Okay, so going to software and assign, and okay, and click on OK. So you can see the load is applied downward, and now uh, our footing area having some soil pressure also. Okay, because this footing is under the soil. Okay, so soil exerted some load downward to this footing slab. Okay, so this load is we having the load of in our case overburden soil pressure on footing is 14 kilonewton per meter square. So we also applying the load on this slab, 14 kilonewton per meter square load. Okay, so select this slab one by one, and going to assign load data, and going to surface load. This load is detect it as live load. Okay, and it applying gravity direction, and the load value is 14 kilonewton per meter square. Okay, all are remaining all same, keep same. Okay, and click on OK. So you can see a load are applying on that. Now at last again selecting that four slabs, and going to assign support data, and going to soil property. Here by using this we provide the soil subgrade value. Okay, the soil which is below to this slab is having some subgrade modulus. Okay, so for that again I am showing how to do that. This footing is resting on the soil. Okay, the soil having some sub modulus of subgrade, so we should provide the property of soil uh, as called as modulus of subgrade. So for that, selecting all four slab one by one. Okay, I am again selecting 1 2 3 and 4, or I am selecting all slab, going to assign, going to support data, going to soil property, and after going to soil property, modify and show property, and you can see here soil subgrade value. So for that property name, take as soil property, the soil pro, you can write as soil pro, and you can give their modulus of subgrade modulus. But what we take the value of modulus, subgrade modulus, so we can find that by this expression, the subgrade modulus of soil is equal to soil bearing capacity divided by settlement. So our soil bearing capacity is 150. So here I am putting 150, and our the settlement is maximum settlement we can allow is 9 mm. So we put this value in meter 0.009. After solving this, we get what a value of 16667. Okay, so this is our subgrade modulus. So put this value in place of subgrade modulus 16667. Okay, and click on OK. So we are also applying the subgrade mode. Soil subgrade, you can see at the bottom of all the slab, this the soil reaction are exerted. Okay, this all support having the subgrade of modulus of 16667 kilonewton per meter square. Okay, and this all four slab are same. Okay, these all are jointed together. Okay, software automatically assume that the connected the connected slab are a unit member, a single member. Now we are modeling, we completed now. So we can go for design now. Okay, before that, going to define load cases. Okay, how much load cases are applied. So for that, going to load case and modify show cases, not that. 1 minute, add copy of case, add new cases. So load cases are already generated. So modify cases, click on modify cases, and you can see there the load cases are not need to define. Now last thing we should do, going to check the design load are according to which code the design combination will generate. For that, click on design, click on design preferences. Here the code are selected is American code. So for first, remember to select IS456 and click on OK, and then go to define, and then go to load combination, and then go to add default load combination. Okay, default load combination we are providing for service normal and strength ultimate, and click on OK. Four more load combination are generated here. Click on OK. Now you can run analysis. Click on run analysis, and before that, save it as Skylab second assignment. This is my assignment, therefore I am saving it as a time assignment. So this second 1 minute second, and save it as. Now your run analysis is running now. Then it take very less time because footing is not too big and complicated. This is your analysis is completed. Now you can interpret various results from the model explorer file at your left side. You can see here. Okay, you can check all reinforcement by going to reinforcement detailing. This is my video. I hope that you like that video. Okay, and I recommend you to join the free course of Skylabs. Okay, during this COVID-19, it is totally free, and it will help you to understand the software, ETAPS, and SAFE. Okay, it is totally free. I have learned from that, and I hope that you will also learn from that. Okay, this is my project, and I was completed it. Thank you for watching video. I am I am closing that video. Thanks for watching.